I ask one pedantic question just
Sure.
before we start, right?
Mhm.
Because the squaring the circle is very dear to my heart, and I'm just curious when you say exact, right? And you say exact to 17 decimal places in GeoGebra. Does
Mhm.
that mean that there's still at 17 decimal places out, there's just something just missing? So you're at 99.9999999%, but there's still something missing in the exact squaring of the circle.
No,
Or
it's
are you
just that
claiming that it is
GeoGebra,
100%?
I believe it's 100%.
Okay.
It's just that GeoGebra limits you to 17 decimal digits, but
Aha.
we have no
Okay.
mechanism to measure beyond that.
But
I get
also,
you. Well,
folks, if you draw this by hand, your pencil will have a thickness, let's say 0.5 millimeters.
yeah.
And that's going to
Anyway.
only be good for 99.9% accuracy anyway.
Forgive my inner nerd. We'll park him now. Please, Robert, this is wonderful. Thank you so much.
All right. So this is, on the Gioconda, the Mona Lisa, the Madonna, the Virgin Mary, the Handmaid of God. And I'll go through these pretty quickly, but don't hesitate to stop and ask questions. I've done a lot of the works of Da Vinci to decrypt them, and it all relates back to the same topic. It's the journey of inwardness and self-discovery.
Mm-hmm.
So this is a sculpture I made. So I started sculpting a few years ago as well. And for me, it was an alchemical process. But this, I usually work with clay and then turn it into bronze. In this case, I kept it clay and then went with a gold leaf. And there was a reason for that, because basically I didn't even realize that there's an ancient Kabbalistic process to make a golem, right? And this is the reference to the Genesis part where God is making Adam out of clay, and then he breathes life into the man. Now, in the Kabbalistic sense, I didn't even know I was doing it, and I posted a picture of what I was making when I made this, and I titled this guy the Water Bearer, right? And so when I posted it, somebody said, "Hey, you're making a golem. That's like what they do in Kabbalah." And I was like, "What?" Again, I had no clue. I just was drawn to doing it. I've made several sculptures, but at the top of the head in the ancient Kabbalistic sense, the rabbi comes to a certain point in his life when he does this, and he puts the word emet on top of the head. Now, emet is Aleph, Mem, Tav. So Aleph Tav is Alpha Omega, because Tav is the last letter of the Hebrew alphabet. Mem is in the middle, right? And it represents water, right? But the word together, emet, means truth. Now, I find it very interesting that in the English language also, and people would say, but those two things aren't even related, right? English language with Hebrew? No way. How could it be? Well, believe me, trust me, man, there are a lot of words like that. Like in Korean, the word for spirit is shin, right? And the word for the same word in Korean, that shin becomes shen in Chinese. It's shin also in Japanese. And in Hebrew, it's also shin. Wow. So how is it that all of these things were connected? Well, because probably at some point in time, everything originated from one language, right? And that's exactly what it says in the Bible too. Who knows? I don't know. But I'll tell you, I found tons and tons. The reason I learned 8 languages because I found all the similarities between the languages and found a process to learn language.
Wow.
But basically what this was very interesting to me, because I noticed some proportions that were matching up to this. And we'll come back to that in a moment. So comparative analysis of the proportion of the Mona Lisa versus the Vitruvian Man. Okay, Vitruvian Man is kind of the iconic, just as you were talking about, Scott. We tend to think of Vitruvian Man as not fair, right? Because it should be something so iconic that it represents all of mankind, not just one gender of mankind. And so we have the Mona Lisa also. And so that the Vitruvian Man wouldn't be left so lonely, right? When you look at Vitruvian Man was made, the first reference to it in the literature was about 1487. And I believe, because I found references to this in the Codex Atlanticus, that Leonardo ended up going to Egypt for 3 years. Now, all polymaths always end up in Egypt somehow, some way, right? That's why you guys need to go, because it's part of your journey, right? You definitely need to go.
You bet.
But I mean, Plato did, Pythagoras spent 30 years there, right? And they all go to attend the mystery schools. Now, there was a sultan at the time during the Renaissance period that went by the name of Sultan Kate Bey. He's the most famous sultan during the Mamluk dynasty, right? So this is the same time as the Ottomans, and these were kind of like a break off, and they were very hostile against the Ottoman Empire, but they had control of everything south of Turkey, so Syria all the way through Egypt. And Sultan Kate Bey is recognized today for being the guy who probably had the biggest expansion of architecture in, Egypt at that time, in Cairo. And it's sort of like internal smaller city fortress called Babylon. Now, there's a letter in the Codex Atlanticus, the reference is 1336 and 1337, that basically shows that the letter was written, it was a draft letter written to the Lieutenant Devatdar of the Sultan of Babylon, Cairo. And it goes on to explain inside the letter that the Babylon that he's referencing is not the Babylon on the shores of the River Chober, but rather the Babylon that is in Cairo. Now, when Alexander the Great, conquered and took over control of Egypt and established the Ptolemaic dynasty after him, they renamed part of Cairo as Babylon. So in this letter, Da Vinci chronicles his very detailed exploration all the way to Egypt, through the mountains of Turkey, and he references something called the Great Taurus Mountain, the Bull Mountain. Now, everyone thinks that that's a reference to the Taurus Mountains in Turkey, but actually it was a reference to the Great Pyramid. He said, at last, we finally arrived in Egypt, right? And we finally arrived in Babylon, Cairo. And along the journey, he describes in great detail his experience in a cave. There was a great cavern inside this Mount Taurus. Well, most people don't know that the original name of the Great Pyramid was Bull Mountain. And in fact, the entire Giza Plateau, the original name of which was Taurus backwards, Ras Tau. The Bull Mountain he referenced was the Great Pyramid. Now, we believe that he had access to maps and he encrypted it all inside Vitruvian Man. And then the horizontal lines that you see here, and he cut his man into 14 parts. And you can see in the reference above, it basically mentions 1/14 right here. I don't know if you see my cursor, it's backwards writing.
Yes.
Over 1/4, right?
Which is the set, the number of pieces
Osiris
was cut into by Set.
Exactly. So what we found, and Alan Green and I worked on this together, is that the horizontal lines mark all of the chambers inside the Great Pyramid. Exactly. Now, that's a whole subject of another discussion. There's a whole TV show that's coming out on that called the Code X as well. And it's going to be on Gaia next month.
Right? Yeah.
On Gaia.
So
amazing. Can't wait to see that.
Leonardo da Vinci's The Last Supper is using the Great Pyramid's exact slope angle as the encoding mechanism, and it's in one of my books.
Absolutely. So we're going to go to that too. So basically what I did is I said, well, wait a minute, maybe there's a chance that Leonardo has made a mosaic of encryption. And it was actually my wife who said, I have a feeling that all the paintings are connected. And so all the paintings that came after his trip to Egypt, which, ended in 1486, are all encrypted. And that's what we're finding, the connection of how they all overlay to each other in their proportionality. So what you notice is that the width, if you place the Vitruvian Man on top of the Mona Lisa, and you place his fingertips to the point of the square, which is matching the exact width of the Mona Lisa, what do you get? So you can see here, it's matching exactly the width of the Mona Lisa, right? And when you place it this way and you have his feet resting on the same, little stand that her hands are resting on, immediately you notice that the Vitruvian Man circle circumscribes the Mona Lisa's head and crown perfectly.
And look at how her eye is perfectly at the top of his head. It's almost like a chakra up there.
Exactly.
I show that in the Mona Lisa, if you put a golden rectangle on it, the center line goes right to that eye, and the square of the construction frames her body perfectly. It's kind of resonating with what you're showing here.
Absolutely right. So the area square was, remember, Euler number, the owl, the wisdom of the owl, right? And obviously was something that either Da Vinci knew outright, which I believe he did, or consciousness just did it. But Euler and pi is what's defining light and light speed as well, and time itself. So what you notice also is that there appears to be something on the left wrist and the right wrist. So you'll notice if you look at the right wrist, there's something hanging down, and there's something on the right wrist. But something you'll really notice is on the right wrist, there's another line here. So there's one line here of the 14, but there's actually a 15th line right here, which is creating like a cuff of a look, right? And on the right, on the left side, our right, you can see the faint trace outline of a letter A, very faint. You see these lines right here? And basically I drew it here on top.
Yeah, I do see it. Yeah.
And another line comes across here, which is kind of the, the sinew and sort of like the tendons of the wrist. Now, it's interesting because, is there an A on the Vitruvian man's left wrist? Well, I discovered the alpha omega inside the king's chamber on the sarcophagus rim in 2018. And no one had seen it before. You can look it up. And it's like, there's tons of graffiti in the place, but this is not graffiti, because this is interestingly 5.605 inches in width, which is the pi times 10 square root, the square root of pi times 10. And the room itself of the king's chamber is 31.4159 meters exactly. So now you've got this thing. It's like, well, wait a minute, that's inches, that's meters. How could this be? Is the pyramid something that was actually built on several different measurement systems?
Yes, it is. And I've showed that both measurement systems, metric and imperial, come out of the Great Pyramid.
Exactly.
To me, that you're finding that in a different way.
Yep. And here it is right here. And all the mathematical constants that I've found, and this doesn't look like graffiti, and there's a patina on it that looks as old as the sarcophagus itself. And here's the omega, and here's the alpha.
And I just want to point out that if you think we're crazy for saying the metric system is coming out of the Great Pyramid, it sounds like it, because we know the metric system was invented in 1799, but it also is based on the dimensions of the earth. And so it's very plausible that the metric system was used in the past, because it's an obvious way of rationalizing the meridian of the earth. And
that's
then
right.
Forgotten and then recreated millennia later.
Absolutely. And, as early as a few thousand years ago, I don't remember the exact date. I want to say it was like sometime before, before Christ, but I don't remember the exact date. But Eratosthenes was able to accurately predict the exact circumference of the earth, and so did Pythagoras, which is very interesting that they knew this information.
Is that from doing that well experiment in Egypt? The Greeks did?
What the Greeks did was, I think it was Thales, right? And Eratosthenes both, who basically cast a shadow, right, in Memphis, and then one up in Alexandria. And they could tell based on the length of the shadow cast at the same time of day. They measured it at the same time, right? And they were able to tell from that the exact arc of the earth, which was a 7-degree arc, right? And they were able to derive from that, based on the distance, what the entire circumference of the earth must be.
Yeah.
That's so cool.
Which was pretty amazing. Actually, there's a good video by Carl Sagan who did this thing on that. But what I'm focused on now is, what is this thing on the Mona Lisa? Because I'd noticed this before, like this omega that's on its side, kind of just hanging out in the middle of nowhere, right? And just to see this here, you could see it pretty clearly, right? What is this? It's got like some chain on it and just kind of hanging out doing nothing, right? What is that all about? So I decided to look more closely at this because it also looked like the omega in the Great Pyramid, right? This is the omega shape that's right next to the alpha. Now, also the Vitruvian Man, you can see here that he's got a cuff, right? If I zoom in on this, so I can get a little zoom in closer, you see how there's an extra line right here? There's no line on this side, right? And Da Vinci does everything deliberately, right? Extremely deliberate. He's famous for encrypting these things. And then it looks like there's almost like a chain and a very faint looking kind of shackle that's hanging off of this cuff, as if he's escaped somehow, right? He's gone from something, and he's not attached to something.
Do you think that could be Plato's allegory of the cave that he's referencing? Like the prison,
Could be. Could very well be.
Like coming out of the cave and seeing a higher dimensional reality.
Right, absolutely. So for some reason, it's like not letting me get back in this now. I zoomed in on this.
To share and reshare. Sometimes Zoom does this.
Hang on one second.
So man's being a prisoner and he's escaping the prison.
He's escaped the prison somehow, right? Or maybe
he perceived belief in the body as a prison of the soul, and
could well be, right? Could well be. And this is coming back up now. I don't know what's going on with Apple today, but this is like not acting normal, that's for sure.
Yeah, I was saying off air that I tried to open my iPad today and the password didn't work. And I know it's the right password. So
yeah, they've probably been attacked by Russian hackers or something because of right. That's seems like something's going on with them today because it's not coming back up now. So, but basically as it's pulling up here, you've got this cuff that's hanging out in the middle of nowhere on the Mona Lisa. And what I'm about to show you is that when you place the proportions of his fingers right up against the width of the Mona Lisa, lo and behold, his wrist ends up right inside that cuff on the Mona Lisa. And it's a perfect match. I don't know what's going on here.
Wait, the Vitruvian Man's wrist lines up with what on the Mona Lisa? With the cuff.
It lines up with the cuff.
So like his arm is like in the handcuff, or the handcuff is hanging down from it? Like,
no, it's in the handcuff.
Okay.
Like as if he's sort of shackled to her.
Okay.
Right. So on the Vitruvian Man, he's got a shackle. It looks like there's a shackle hanging down, right?
Yeah.
It's open and he's escaped from, right? But it's now when you place the Vitruvian Man on top of the Mona Lisa, then all of a sudden you'll see that his hand ends up exactly inside that shackle.
So what I take from that is that like it's a metaphor maybe for the body and the soul, and that the soul is shackled to the body. What do you take from that, Robert?
I don't know, to be honest. I mean, it's a very interesting thing. I really don't know.
Well, I know the Vitruvian Man has the square and the circle. And to me, the square represents the body or the physical aspect. And the circle represents the transcendent, like soul aspect. And so just within that diagram, you have an interplay between those two polarities. And it's fascinating that you're drawing this connection with the Mona Lisa. And who's to say that your higher self wouldn't be the opposite sex? It's possible.
Well, very likely. I mean, that's what Carl Jung would say, right? That
the anima and animus.
Anima and animus, exactly. So let's have a look at this, and we'll try to draw some conclusions, right? So as we place this on top of, right, using the exact same proportions.
Sorry, just so I get my head around this correctly, Robert, the omega is kind of pointing inward. It's not pointing downward. Isn't that right? It's kind of on its side. It's an omega on its side. Okay, I get it.
It's an omega on its side.
Letter C, sort of, you know.
Yeah,
so
yeah. Oh, I see it now. Yeah.
When we match the width of Vitruvian Man's square to the width of the Mona Lisa, and then notice that her crown is perfectly inscribed, right, within the circumscribed circle, right? Then look what happens with this omega. It ends up right on his wrist.
That makes a beautiful connection also because it's lined up with the square, which is the body, the physical.
That's right. So that's what he was doing. He's basically saying he's basically conformed the Mona Lisa to the square. So, you know, in the divinity process, right, the thing we're supposed to do, the whole purpose of squaring the circle is to bring the divine out within ourselves. And that means the masculine, the left brain, needs to embrace the right brain and recognize that the two don't operate independently. They're actually just complements of each other. And they're never away from each other. So this concept of a shackle, we are tied together. You know, we're not going to be separated. It's only our perception that drives us to believe in that separation, even though it's not real, right? So the shackle fits perfectly over the wrist of the Vitruvian Man. So what else does it do, right? And again, all I had to do was match the width. So it's a beautiful metaphor. The width of the Mona Lisa exactly, and this is exactly from the high res, you know, of that you can find online. You also find that the feet end up on top of this little platform that she's resting her arms on. And even in perspective too, it's kind of mind blowing how well he did. And then look, the line of the circle is matching her clothing on her arm.
You know, I wrote a book on Leonardo's artwork, and I have shown how it's based on the golden rectangle very often. And I believe that he always started his constructions with sacred geometry. And then after he did his drafting, he then sat back and thought, now, how can I turn this into a portrait? Or how can I make an artistic composition based on this geometry? And then he does so, and you're not aware of the geometry, like on a mundane level.
No,
but there is something in your brain that's doing all this processing that is aware of that. And I believe that is why, in fact, we think his artwork is so beautiful, because it's resonating with these deep structures in our brains that analyze the geometry and find golden ratios, for example. And we're getting this hit like, oh my God, that's so beautiful. I mean, this thing is a temple of the golden ratio right here, the Salvator Mundi.
Oh yeah, Salvator Mundi is a temple of golden ratio, but even more, you'll see here, you know, obviously his hands are sort of representing Alpha, and then his clothing represents the Chi, and he has 8s written all across here, 8, 8, 8, 8, 8, 8, which represent Christ consciousness. But what most people don't understand is this is actually the side slope of the Great Pyramid in its Eris edge. And this is the King's Chamber upside down.
So it's inverted. It's the pyramid inversé.
Yep, exactly. So you'll see that in a second. So you got Alpha on one side, Chi, Omega. And our last trip to Egypt was called the Alpha Chi Omega, you know, Egypt 2021 Alpha Chi Omega. And this is, the Chi represents this change from duality into a trinity. So just again, revisiting the proportions, all I did was take the exact proportions of the Mona Lisa and then place Vitruvian Man over it, where his fingertips are going to the exact edges of the proportions. Now, by the way, on the backside of the Mona Lisa is the number 432 and TH, which is TH is another Rosicrucian symbology, which he was a Rosicrucian, for Thoth. So taking the Salvator Mundi is exactly, this is the pyramid when you're looking at one of the corners. The slope in the center is 5184, but if you want to climb to the top, you go up the edge, right? Because it's 10 degrees less, 41.843. And that's exactly what you have here in his garment. And then even the off-center King's Chamber, it's not centered, right? As you can see with this like stone here, it's basically an amber stone, is representing the King's Chamber right inside here.
Well, your
One
diagram,
encryption.
the 51.84, to me, that looks more like a 60-degree angle. It seems like it's not wide enough there.
No. This is looking at it in perspective. So this is not meant to be right.
Oh, I see.
You see what I'm saying? This is the actual proportions of the Great Pyramid. The slope angle of the Great Pyramid is 5184.
Well, that's why you
And
say
it's at the center.
percentage. I see.
It's at the
because
center, right?
Yeah, it's
a
turned 45 degrees in plan.
exactly
Yeah.
right.
I'll get you.
So if I drew it absolutely correctly, then I would have the point probably down here, right?
Yeah.
And it would be closer to his chin at the base of it. Okay.
Mhm.
But we see this same proportion of 5184 right here inside
Yeah.
the Mona Lisa.
Yeah,
Not
this
Mona
is
Lisa,
like
in the Last Supper.
The
And
Da
that's
Vinci Code
what you
right
showed
here.
as well, right?
Yeah.
So this is the subject of the Da Vinci Code, but Dan Brown looked at it and said this was an equilateral triangle. It's not an equilateral triangle, it's the Great Pyramid, exactly.
Yeah.
And by the way, that this right here is a representation of the sarcophagus, and the Last Supper itself is the room of the king's chamber of the Great Pyramid. The
You gotta-
Last Supper
Wow.
itself is the room of the king's chamber. This is the representation of the sarcophagus, this portal that goes underneath into like a little dining area that was for monks. And basically this whole room is the symbology. It's like a map of the king's chamber of the Great Pyramid.
Interesting. Yeah.
So this is, an overlay that we did showing that the chambers matched with all the horizontal lines, the 14 cuts, which then means there's probably another chamber far below the pyramid down here. And we know also that there's a line here at the throat, and there's one at the ajna, or the third eye, and then the crown. And now look, when you place it with the Mona Lisa, you've got her eye right on top of his head, sitting inside of a moon, right? And this is the relationship that is already inherent. And we believe that the king's chamber is representation of the heart chakra, right? Which then leads through the throat, that there already is known to be a large void space that leads up exactly to this spot right here.
And the heart is off center in the body.
And the heart is off center. Exactly.
Mm-hmm. Mm-hmm.
And see, the shape of this is the same as that Salvator Mundi.
Yes, it is.
And
That's
they
mind blowing. So
really
that's
need
the
to-
king's chamber. Can I ask, the higher chambers that you have a question mark on, we don't know if there are actual chambers there yet, do we? Is
Well,
that
we
kind
know
of a
that
hypothesis?
we know that there's a void space that leads up to that at the exact same angle, which
Wow.
is 26 degrees approximately,
Wow.
that takes it straight up to this point at the throat chakra. And it is widely believed by Egyptologists as well. And I mean, that void space is large enough to fit like an airplane in from length. It's huge.
Oh my
So they
goodness.
found it with the muon, with their ground penetrating radar and muon transfer technology. And that was found in 2017 on my first trip. The day we were there was the day they discovered it.
They really need to go in
Really
there.
coincidence.
Right.
Another, happy timing. Hey,
That's right.
Your first day, and they discover that. That's mind blowing. Like, if there's these two higher chambers that roll up with the ajna and the crown chakra,
Exactly. And you could see here, the proportions also, right? So here's your 792, right?
Mhm.
7920. And this is exactly 7.92 inches on the Vitruvian Man. If you took these exact proportions, and 8.64 inches is the circle that he left, which is it's actually 8.65 inches. And then you've got all those same numbers that are matching up. And of course, this
Wow.
part that sits on top of the earth is 2.16 inches.
Yeah. I never knew that. And this is the Vitruvian Man, the original drawing in exact measurement. has
Exactly.
these numbers.
Yep.
I never knew that. That's okay. Wow.
So you've got this. So Vitruvian Man informs each of the relative diameters of the planets in the solar system also. And I found this by taking the center, right, of the square and placing it over the center of the circle. Now, what I was talking about earlier, what I was saying that you can derive the doubling of the cube simply by taking these proportions and just taking from here, the navel to the upper right corner turns out to be the cube root of 2, 1.25922, versus this being a unit of 1. So from here to here would be 1 unit.
Mm-hmm.
This becomes cube root of 2. So from that, you can now
Wow.
double the cube
Wow.
in this construction box.
Where's
now-
I'm sorry, where's the 1 and where's the cube root of 2 again?
So the 1 is the base right here. So you take half of the base. So it'd be from here to here.
The
Okay.
corner of the square.
Mm-hmm. Or you could also
Mhm.
say it's just from here to here,
Okay,
right? And the cube root of 2 is from here to here.
I see.
From the navel to the corner.
Yep.
Mm.
Beautiful.
So, and I've
Yeah.
verified that with GeoGebra, again, 17 decimal digits of accuracy. Perfect.
That's amazing.
I know I find
That's
things that
amazing.
are amazing sometimes, occasionally, and then I'm like, I gotta triple check that because I just don't even believe it, like you're led to something and then you're like, no, is that real? And then you double check it, you triple check it, and you're like, oh my
My
God,
God,
it is
it's
true.
So
real.
draw a square on GeoGebra with, the square root, the length of its side is going to be the square root of Euler, which is 1.648, right? And then draw a circle with a radius of 1, right? And you're going to have and then measure from the center of the circle to the upper right side of the square, put them both at the same base level, and you'll find it's exactly cube root of 2.
Mm-hmm.
So in this case, I took the square, I moved it up to the center of the circle. And what I noticed is that these numbers showed up again in these relationships.
I love this.
So the Euler square and the pi circle. So when you actually inscribe them within each other and then just do a fractal of these, like just keep going out into the distance, like a little tunnel, what
Mhm.
you find is that the sun shows up right inside here. These proportions, here's your 8.64 inch that matches the proportions that Da Vinci gave us.
Mm.
This one matches because the way it's all based on wave doubling, right? And so the circle at the center here is 2,160 miles or 2.16 inches. And that's the exact diameter of the circle that's above the Vitruvian man's head that completes the circle, right?
Mm-hmm.
Mercury shows up in here as well. And these are all like 99.99% accurate.
Wow.
And Mars does also.
And the Da Vinci square and circle those are the ones that come from the diagram in orange there. Is that right?
Yep. The Da Vinci square and the circle. And all I did was I just took the exact same from that point. I then, exascribed a circle around the Da Vinci, orange, and I made it thicker so you could just see it. And then I inscribed within, each circle a square, and then just kept that process going in this pattern that you can see here.
Yeah.
Yes, I see it.
And in doing this, every planet in our solar system lines up. Now, Earth shows up exact as well. But what's interesting about Earth is that you have to add one other thing. So you inscribe the square within the circle that Da Vinci gave us, and then you do a perimeter match, right, for that square to its circle.
So in other words,
Square the circle by perimeter.
length.
Square the circle by perimeter, and then you have Earth. Or circle the square, right, by perimeter, then you have Earth. It's
So
a
there's
perfect
this
match.
geometric harmony in our solar system, which is clearly not a human thing, but it shows that there's a very deep level of geometric order that does not compute in terms of modern physics.
Absolutely.
But what to me it implies consciousness, because it's clearly a beautiful conscious pattern that you've hit upon here. That
So beautiful.
that our solar system conforms to.
Yep, absolutely. And you can see here that the circle in the center is the same size as this, and then it fits perfectly right here too, on top of this Earth.
Mm.
So there's
right? And then
there's the classic
it out.
Earth squaring the circle.
So this
diagram.
is the same
Yeah.
right here. And then once you have found the perimeter match to the square, right? So the circumferential match. So the Earth is right in between this one and this one.
Yeah.
Right here. And then the moon fits exactly on top of it.
Yeah.
Amazing.
Jupiter is also just, 10 times smaller than the sun. So it becomes another form of fractal.
Oh, is that right? I didn't realize that.
Yep. So Jupiter is 86,400 miles. The sun is 864,000 miles. It's actually 865,000. So there's this very small variation, but that's why if the first time I looked at the circumference of the sun, it was 2.714 million miles. Now it's 2.72 million miles, right? And it fluctuates. It'll go back between, 2.714 and 2.72 and often be at 2.718. It's exactly the Euler number. And you could see how the Saturn is more oblate, but it still fits inside this, right? As planets, Walter Russell did a lot of work on this and talked about how planets, when they get to the center of the solar system, they get really big and bloated, like we get fat in our midlife type of thing, right? It's the same type of thing, and we get some moons.
Wow.
So we live in a matrix then, in a sense.
Without a doubt. Without a doubt. And it's a really cool matrix. And life kind of sucks and it feels like a prison until we realize, I think that's also the metaphor of the shackle. Until we realize that the aim of the exercise is just to fall in love with the journey and the ride.
And there's also a beauty in the pattern as well. Like there's a beauty and an order. And I feel a benevolence and a goodness in this pattern as well, personally.
Absolutely. So this is the method also to get to the squaring of the circle, right? So, once you take and you combine, the thing that is divine is to link up the circle with the Da Vinci square. So here's the Da Vinci square. And you do that by drawing the lines to its base corners. Now, this proportion is something that you see very many times on our dollar bills, right? And this is exactly the squaring of the circle that Da Vinci did. And this is Euler versus pi.
Wait, can you go back one? So the big circle is the Da Vinci circle, right?
Da Vinci circle, that's pi.
And the square is the Da Vinci square.
It's the Euler square by Da
And
Vinci.
so the triangle is actually the thing that's connecting to the top of the Da Vinci circle and the
Correct.
bases of the Da Vinci square.
Yep.
Okay.
It's beautifully simplistic, but this is also the method that I use to square the circle. So when I told you that the most important step is to get this right, and it is that you have this line, right, that comes down here, and it's actually just barely tiny bit on the inside of this, and then you get a perfect Euler number. Now, once you get a perfect Euler number, then from there, it's easy to find pi as the square, because what you do is you draw a line from here to here. So you crisscross the square, the Euler square.
From H1 to K?
Yeah, from H1 to K and then L1 to L.
Okay.
Right. So you draw a line, but then you extend that line to bring it all the way out to here.
All right.
On both sides. So it doesn't, you have these two as your reference point. So you just extend the line, right, with the ruler. And then what you do is you find the point where the circle intersects the square on the bottom side of it. So right here, not here, but right here. And you've got a point here now because you extended that line, the diagonal line.
Yeah.
On both sides. So you take a line from here to connect it to this point right here.
Okay.
Do the same thing on the other side. Connect it to this point, and they'll crisscross in the middle. But where that line intersects the circle defines the exact position of the pi square.
Okay. Now this reminds me a lot of the star cut in how, I don't know if you're familiar with the star cut diagram. Oh, I've got to tell you about that later, but not in this podcast, but it's a whole journey in itself. But it gives, it's a way of dividing any segment into from 2 to 12 parts. And it's very much in this spirit where there's intersection points that you kind of crisscross, and then it reveals the place where you make that exact division. And so this is similar geometrically to that other pattern.
Makes
We must
sense.
share. It's a guy called Malcolm Stewart. He wrote a beautiful book called Patterns of Eternity. I
Mhm.
think you'd love it, Robert. We'll share
That's
it with
awesome.
you.
We're actually planning a workshop on that topic.
Well, it's interesting you mentioned that, because this also gives you a prescription of how to separate a line into thirds. So for example, where this line, so you've just got a crisscross across the square, and then you've got this line from here down to here. And these lines are really important, because any square that's centered on the circle at its base must have its corners on these lines.
That is the star cut, a square
Wow.
with the lines connecting to the midpoint edge.
That's very cool.
Yeah, so you've actually found that same thing in a different way.
Mhm.
Yeah, that's so cool. And I love that you don't know the star cut. You know what I
No,
mean? It's
yeah, I
kind of
don't.
like, it's like, hey guys, check this out, you know, and
Yeah.
you're like, wait, what? Star cut? You know, this is
Yeah,
super
totally.
cool.
And that's
Yeah.
math is, and geometry is like that. You can enter in any door, and you can get to these different rooms through different routes. But it's
So,
always,
I love it.
It's always like pure truth. So you know you get there and you know it's right. You know.
Pure
Well,
truth.
What's great about this also is it's giving us a relationship that you can see that this line from here to here is 1/3 of this line entire length.
Yeah.
Right. And this is a 24, 26, and 10 relationship. So 24, 26, and 10 relationship. Now, that's basically a Pythagorean 5, 12, 13 triangle.
Yeah.
Now, where else do we see this? Right here. And interestingly, when I decided to place this on top of the Mona Lisa, look where the eye is landing. So in the exact same proportions that I used for the Vitruvian Man. The eye is landing exactly
there. Yeah.
Exactly. And since her shoulder is coming more out on this side, I flipped the image. And now you've got Eye of Providence in the exact same position as Vitruvian Man. And look, it's even got an aura around her head.
Yeah, that's very cool.
So what else might be encrypted in this thing? And obviously there's lots, right? Lots and lots. But, you know, I then, you know, made my own version of Vitruvian Man, right? And I didn't even try to match the proportions. Of course, he has a crown, so his head's a little bit, you know, askew, but it's intended to be right up in here. And it was matching the proportionality, right, of Vitruvian Man. And when I placed it even over Vitruvian Man, the part that was eerie was that his face was like a perfect match. I've got a video of that as well, which was kind of bizarre. Like literally his facial proportions were like exactly landing in the precise same spots. It was kind of freakish.
Wow.
So basically when I placed that man right on top, that started off with this, you'll see that her eye is right in his crown. And on his crown, it says Alpha Chi Omega. Now, the reason I raise this to you is because, you know, last night, and I'll finish with this, I was up till very late. And you know, lots of people know that I'm very interested in, you know, the squaring of the circle. And that I have a logo is also kind of well known.
Just go to your website and you'll see the logo right away.
Yeah, you see the logo everywhere, right? It's like, it's an important thing for me. And I don't even know why it became such an important aspect to me. But what I realized was that, okay, here we go. So this is GeoGebra, and this is a pretty complex, in-depth analysis I did last night. So I'm going to have to open it in the app. I'll pull up here in a second. My logo was two triangles that were, you know, kind of like intersecting each other. And they were long, right? So they used to be triangles that would go all the way out to these points here. Right. And what I noticed is that, and I just found this last night, is that the exact proportions of my my logo that I chose, which represented merger of opposites, informs exactly squaring of the circle.
And is that because you decided on your logo to truncate the triangles, like and
No,
cut off the edges there?
I had no
earlier on?
clue. I just drew it.
No, but your logo doesn't it have the truncated corners like currently?
Yes, I truncated the corners. I truncated the corners about a year and a half ago, and I did a whole thing about it, right?
Yeah, so there you've got the truncated corners on your logo, but they totally line up with the squaring of the circle here, right?
Yes, in all three ways. So the whole basis of this, if you look at this, right, here are the proportions of this. And where the truncation occurs is exactly at the red circle, which is a squaring of the circle of the red square that is here, right? The larger red square is the same area. Its perimeter is matching the red square here. And you can see where there's an intersection here of these circles, these internal circles. This is the moon. It's the exact same proportion of the moon. That same moon that we just saw on the planetary analysis thing. It's identical. So this has also led to another solution to how to draw the squaring of the circle, but I have not finished that part of it yet. But I know that it will. But basically what's happened here is you got this truncation along this red circle. The red square, which is where these circles are intersecting right here, right? Let's see if I can zoom in on it. See that where those intersections occur? That's giving me the perimeter that's equaling the red circle. Now there's a blue square that's outside of it that is actually completing the square that's around my logo. And when I take that value, it is matching, right, the blue circle in perimeter and circumference. So the blue circle is just framing that circle from the moon, right? That's coming down to here, this point as well. And the truncation on the outside also led to a truncation on the inside. And that truncation on the inside is matching the green circle, which is the pi. If you consider that having a value of 1 for its radius, this circle is pi and this square is Euler. So I had no idea when I made this logo that I had the intention behind it, that it would represent merger of opposites, masculine and feminine. And of course, this moon fits exactly right in the center as well. I had no idea. And I only discovered this last night. So that makes me wonder now, because clearly I did not have my conscious intention to do this, right? That was not my intent.
But don't you think that's what Leonardo experienced also?
I believe he must have.
And it's a question whether he was aware of these resonances and how much was he really as an individual aware. I kind of speculate that in a way humans are like mound building termites, in the sense that if you look at the termite mound, it's this wonderful architecture that has air conditioning and farming and all these amazing complexities that no single termite mind could even conceive of. It doesn't have the neurons for it. And yet, as a species, it somehow is able to manifest this staggeringly complicated and beautiful architecture. And I kind of wonder if we have like a mind that transcends our individuality, and that it kind of speaks through us as individuals, but we might not be aware of what we're doing. And I think
you're right.
It's wonderful to become aware of that, and say, oh my goodness, look at what I did. I didn't know I was doing that, but nevertheless, it's resonating with these harmonies.
So let me show you this one last thing that I mentioned earlier, I touched upon, but I want to make sure I hit it here, because we all know that, this is our big number calculator, by the way, and I'm very excited about this technology. It's in constant time. If you go on Wolfram Alpha, you can get like 500 digits, and it takes quite a while to have it distribute that number of digits out to you. I kind of measured it on a kind of stopwatch last week, and it took several minutes to get there. What this does is I can actually issue an accurate value for something like, the square root of 2, and I can see how long that digit string is, 301,000 digits of accuracy.
So you have a really excellent algorithm in here that can do this in a second.
Yep, exactly right.
How many digits? 30,000 plus.
No, 301,000.
301,000.
Yeah,
in that
so-
time.
Why
I'll take
isn't
the
it
square root of
333,000, Robert?
Because that turns out to be 1 megabyte exactly.
Oh, okay. I see.
301,000 is 1 megabyte. Because it would
Okay.
be 1 million characters of binary,
Okay.
right?
Because
Whoa.
binary uses powers of 2. It's
Mhm.
sometimes
Right. So you just take this, it's 3.32 is the conversion factor, right? Of 301,000, which comes out to be, basically 1 million. So I can take this and see the string length, 301,000 digits. So that would be about 91 pages of text in a Word document,
Mm-hmm.
right? And in constant time. So that's kind of a feat, right? It's a feat. And nobody offers this, and we're going to release this for free for everybody. In fact,
Wow.
we're going to do a whole learn to earn or earn to learn type thing. So you can contribute, because our next generation calculator also has visualization and even music. It will convert your
Amazing.
visualization into sound. So you can
Mhm.
listen to the geometry you're making.
But
Right.
there's so much more that you shared with us that this can do. Like in the back end, you have like a whole compression algorithm that you
Yes,
figured out.
yes, absolutely. And so that relates to what I'm about to show you. So we know that the golden ratio, right, is the square root of 2. It's the equation you mentioned earlier. Square root of 5, square root of 5 plus 1. So I'm going to put square root of 5 on here, add 1 to it, make it 3, and divide it by 2. And this should give me the golden number, right? The golden ratio.
Mm-hmm.
And it gives me a whole lot more than just the 16 digits I set.
Okay, so you added 1 to the square root of 5 at the top
Yep.
and manually,
Yep.
and then you
added it,
divided
right.
by 2. And so
Mhm.
that gives you the golden ratio.
Golden
How many
ratio.
digits does that golden ratio go to there again? Is it the
301,000 digits.
301,000. Okay.
301,000.
Wow.
That's a lot to memorize there.
That's a lot to
Yeah.
memorize. So Jeff,
I'd win
next time,
well
we'll
on
give you
the
till next time.
Fair
So,
enough. Okay.
so what's unique about this number, though, is what makes it golden. And
Uh-huh.
have you ever really thought about that? And one thing that I believe makes it golden, that it has a property that no other number seems to have. And that is when you take its 1 over x value, it's equal to the same number minus 1.
It's unique in all of numbers. That it
Yep,
does
it's
that.
unique in all of numbers. And so you have a decimal extension is called a mantissa in mathematics. So you've got this identical mantissa, and it's only separated by 1.
So 1 over phi equals 1 minus phi.
Correct. Or 5 minus 1.
Mhm.
So basically what you've got here is this identical number, and it's infinitely identical like this. But if you ask anybody, they would generally say that's the only number that does that. And what I derived from this was a means to be able to compress data. So let me just stop this for 1 second. I'll show you one thing really quick. And okay, here we go. Because if you've got a mirror that goes across this, then you actually can recreate that number string.
We can't see it though.
Yeah, I'm pulling it up. Okay, do you see this now?
Yes.
Okay, so you can recreate this number string because you know that the number has to return to oneness. That one number multiplied by its reciprocal must come back to 1, and it has to have every digit be the same.
It's too small.
Okay, hang on, there we go.
There we go.
Mhm. Yeah, it's coming true.
So what's happening here?
So this is recreating the golden number starting with only 1 digit and with no equation and no other information.
And how is it, what's the algorithm there? What is it doing?
So what it's doing is it starts with 0.6, and then you take 1 over 0.6, and it comes out to 1.666. So then you take the 1.6 and then you take 1 over 1.6 and it gives you 0.625. And then you add 1 to that and then take its reciprocal. And then you keep adding 1 and taking its reciprocal, add 1, taking its reciprocal. And that's what this is doing. And it recreates the entire phi infinitely.
Why does it do that?
Because there's a mirror between the x and 1 over x. So it literally, and I'll just show you.
So you can run phi to infinity then?
Yes,
this?
without any information other than 1 digit.
Wow.
So you can reconstruct it, basically.
You can reconstruct phi. So how do I do it? So you take 0.6, right? 1 over x. So now it tells me the first digit's 1. So now I take 1.6. 1 over x that. Now it tells me it's 0.625. I add 1 to that. Every time it gives me an answer, I just keep taking and adding 1.
Plus 1.
And reconstructing it.
Reciprocal. And then plus 1.
Plus 1.
And then reciprocal.
And then plus 1. Look what it's doing already.
Yeah, it's getting there. Wow.
Plus 1. And then reciprocal. It's a very simple algorithm. Add 1 and take the reciprocal.
Yeah, it's not so simple with other numbers. I'll just tell you that. And it's the subject of patents also. But now see what it's doing? It's recreating the golden number. And it does it infinitely. And it will eventually get to the point where all of the numbers here will end up matching golden ratio.
So you can just do that as long as you like to get as many digits as
exactly. And so what you were just looking at in this,
it's like I see the number of iterations is going up. It's calculating it all.
Yep.
And you can recreate the original string of 300,000 digits.
That's right. Well, this one goes much farther than 300,000. And this was doing it algorithmically using that approach that I just showed you. So we're all black holes and white holes is what I said.
That's so cool. So you know the way the claim is that the golden ratio, it never ends and it never repeats, and there's no pattern can be identified in it. If you're able to run this to infinity, I'm wondering, is there some cool program you could run over that to see, could you identify a repeating pattern? Is there a pattern?
I've not found any patterns yet. But it doesn't mean they don't exist. Now, what irrational numbers do, and this is, of course, irrational, it's not transcendental. Phi is not transcendental.
Because it has an algebraic solution of 1 plus or minus square root of 5 over 2. Whereas like E and pi don't have an algebraic solution.
That's right. But basically what this is doing is it provides a uniform distribution. There's no more likelihood that we're going to see 1, 2, 3, 4, 5, or 6, or 7, or 8, or 9, right? They're all equally likely to be seen. So that's why you've got really strong uniform distribution with irrational numbers. And you don't have to start with if I started with 0.618033987, lots of people on this call would say, oh, I recognize that. That's the golden ratio. But if I started with, 0.9887, 45, 9895, very few people would actually recognize that is also the golden ratio. And the farther out I go in that string, the more and more impossible it is for us to derive that, right? So basically what we did is we took this concept and applied it. And I'll show you that the golden ratio doesn't only exist for the golden number. It exists for all numbers. Okay, so 333. So what's the mantissa of equivalence for 333? It's this. So this is the 1 over x of that same number. So every number has a golden ratio. So of course, if I multiply this by its 1 over x, it's just going to come back to 1. Literally every number has a golden ratio relationship, just like phi does. And we discovered this. And now, because in the same way that we can recreate phi, but we don't need to do it algorithmically, we can do it from an equation. We can compress data.
Of any type.
Of any type.
Any kind of numbers can be compressed.
Any kind of numbers.
And much more efficiently than current compression.
Much more efficiently.
That's the rub right there, the efficiency of it.
Exactly.
I mean,
So
yeah,
look
we
at
can
That's very
zip
cool.
files. We can do that. But can we compress them? How much does a zip file compress something like?
only about 30%, 30 to
30%.
40%. Mhm.
But your thing can go way higher, I believe.
Should go way, way, way higher.
And it happens quickly.
Very quickly.
Doesn't take an age to compress it.
It's constant time.
Yeah, so it's unlike a zip file, which takes a while, you know.
No, that's right. It's constant time. It's an equation.
And that probably has applications that I haven't even thought of in cryptography or
Well, and so
Better that we, guys, I'm just thinking for, you know, the sake of ourselves and our listeners, like we're 3 hours in, you know.
yeah.
I gotta go.
To be honest,
I've got someone
I
waiting
could
for me.
go, I could open up another 3-hour conversation about cryptography and your project in crypto, Robert. Like it's just been a joy, quite sincerely speaking to you, you know. So
Well, we'll
thank
do
you
another
so
one.
much.
We'll do another one.
Yeah, yeah. It would be wonderful to stay in touch, you know. And I hope our dear listeners have enjoyed it as much as Scott and I have. We're probably going to break this into 1 or 2 or maybe even 3 episodes because there's a lot in it, you know. So we can edit it so that it's kind of it's enjoyable in podcast form. But thank you, everybody. Thank you, Robert. It's been an absolute pleasure, and I hope this is the beginning of many to come. You know.
Thank you. My pleasure. Great to see you both, and look forward to doing this again sometime.